Hello everyone, in this session we are going to talk about the chemical kinetics. So we are gonna start our lab with the explanation of the mechanism of this experiment. We are going to review the solvolysis of third butyl chloride in water. Actually, solvolysis is the same as hydrolysis for this experiment because we are using water as the solvent. And we have another work like solvolysis. If we use alcohol, it becomes alcoholysis. So solvolysis is a general term. If we use water, it becomes hydrolysis, or if we use alcohol, it becomes alcoholysis. In this experiment, we are going to use water as a solvent, and water is going to react with the T-butyl chloride. We are going to have the T-butyl alcohol and hydrogen chloride at the end of the experiment. So as you see, the mechanism of experiment is SN1. We have 3 steps. One step is slow and 2 steps are fast. The rate determining steps is the slowest step of the experiment, which is uh, removal of chloride and carbocation of the third butyl. So as you see, after carbocation of the third butyl, which is the rate determining of the experiment, we have uh, carbon positive at the center, and water from O is going to attach to the carbon. So in that condition, this attachment is fast, and then another step is removal of extra H from oxygen from chloride ion. That step is also fast. So we at the end we have third butyl alcohol. So what you need to know, this experiment is SN1, and why we are calling SN1, because we have uh, for the for the rate of the experiment, we just need to measure the concentration of one compound. That's why we are gonna use the SN1 for that experiment. So you see again the experiment mechanism. You need to remember that the rate of this SN1 reaction depends only on the concentration of the third butyl chloride at the beginning. Concentration of the nucleophile here, water, has no effect on the rate of this reaction. So the rate of the reaction is just depending on third butyl chloride concentration at the beginning. With that formula, we call the SN1 reaction of third butyl chloride as a first order reaction. So you see that to derive the equation for the rate of this experiment, we need to define our boundary points. The first boundary point is um, the concentration of the third butyl chloride at the beginning, and which is equal to uh, concentration of the third butyl alcohol at the end, because both are the same molar. For that, we are going to define the rate of the reaction SN1 as a K1, and the and momentum concentration of third butyl chloride. So the rate of the loss of third butyl chloride is equal to K1 as concentration, momentum concentration. and we know that it means a differential equation between the the rate of changing of the concentration equals to K1 and rate of and the concentration momentum concentration of third butyl chloride. If we get the integral from two sides, this equation from both sides of the equality, you see that at the end we have the minus ln, or a natural logarithm of uh, the concentration, momentum concentration of third butyl chloride over the uh, early concentration of third butyl chloride, which is equal to K1T. T is the time here. And you know that the natural log of x is 2.303 logarithm base 10x. So we just substitute what we just remind you. So minus 2.303 logarithm of uh, momentum concentration of third butyl chloride over the early concentration of the third butyl chloride equals to K1T. K1 is just the coefficient. So we have the equation 2. You need to remember that. If you don't substitute 2.303, doesn't matter actually. You just need to know. We just did for making that kind of extra step to make it simpler. So to derive the rate equation, we know that the 1 molecule of third butyl chloride produces 1 molecule of the hydrogen chloride. So we will determine C0, it means the early concentration of the third butyl chloride, and Ct, the momentum concentration of the third butyl chloride based on the concentration of hydrogen chloride. At the end of the reaction, when we have a T as an infinity, all third butyl chloride will convert to HCl. So concentration of the HCl at infinity is equal to early concentration of the third butyl chloride, which means at the T0, the concentration of the third butyl chloride is equal to concentration of the HCl at infinity at the end of the experiment. Now at any time t, we know that the momentum concentration of HCl equals to finite concentration of the third butyl alcohol minus the momentum concentration of the third butyl alcohol. So we can change the sides of the variables, and you see that the momentum concentration of the third butyl alcohol is equal to early concentration of the third butyl alcohol minus momentum concentration of the hydrogen chloride. We know that the C0, or early concentration of the third butyl alcohol, is equal to HCl infinity, or concentration of the hydrogen chloride at the end of the experiment. So we substitute that. So we can then substitute all the end work on the equation 2. So equation 2 is look like this one: 2.303 logarithm base 10. So we have in the we have concentration of in the infinity minus momentum concentration over infinity concentration of hydrogen chloride, which is equal to minus of the coefficient times t. We call this equation 3. So to continue derivation, the value of the momentum concentration of hydrogen chloride is determined by withdrawing an accurately measured sample from the reaction. So we use the titration reaction to measure the HCl. So the HCl is equal to NaOH that we use to for during titration. Referred the momentum concentration of the HCl is referred to a liquid, and then quenching the liquid with the acetone and then titrating with a base. It is not necessary to use a standard solution of base for titration as long as the same base solution is used for all titration and volume of all aliquots are identical. So uh, we know that it is not necessary to calculate the hydrogen chloride momentum or hydrogen chloride infinity because they are equal to NaOH concentration that we are using for titration. So how much we use NaOH, sodium hydroxide, during the titration is equal to the amount of hydrogen chloride. Those amounts are in parallel. So equation 3 is then changed to equation 4. We substitute the amount of hydrogen we substituted with the sodium hydroxide concentration, and then equation we just change the side of the 2.303 to the other side, to the right side, and the final equation becomes equation 5, that the logarithm base 10 of the uh, infinity concentration of the sodium hydroxide minus the momentum concentration of the sodium hydroxide over just the infinity concentration of the sodium hydroxide. For that, we are gonna prepare a bullet with the 0.04 normal sodium hydroxide solution. We need to fill 50 milliliter bullet with the 0.04 normal sodium hydroxide, and then using plastic pipette measure 1.2 milliliter third butyl chloride in 100 milliliter volumetric flask. As you see, we fill the remaining of the flask with the 101 ratio, the same ratio of the water and 2-propanol alcohol solution, and mix with the third butyl alcohol that we have already in the volumetric flask. We use it as a stock solution, that solution. So at this step, for to prepare your infinity solution, just take 10 milliliter pipette and take 10 milliliter stock solution from stock solution in a 125 milliliter Erlenmeyer flask, and add 10 milliliter water and mix well in that Erlenmeyer flask. So the next step is titration at 10 minutes, 20 minutes, and 35 minutes, and 50 minutes and 75 minutes. At 10 minutes, using the 10 milliliter pipette, take 10 milliliter of stock solution into a 125 milliliter Erlen Meyer flask, and then add 10 milliliter acetone. We are gonna add 2 drops of the standard solution, which has a color, so it gives the color for titration, and titrate with the 0.04 normal sodium hydroxide. We just wait till the whole solution becomes pale green at the end point. So then we record the sodium hydroxide that we use to change of the color. So titrate your infinity solution at the end. uh, Add 1 to 2 uh, drops of the standard solution. um, then we are gonna uh, titrate the infinite solution with the sodium hydroxide. Record sodium hydroxide needed for titration of the infinity solution. So as you see, we have the table for 10 minutes how much sodium hydroxide we used for changing from yellow to pale green at 25, at 20 milliliter, 35 milliliter, 50, 75, and infinity. So that's the whole purpose of this experiment. So as you see at the end of the experiment, we are going to make the curve. The right side of the equation is the y-axis, the left side of the equation is the x-axis. So with the use of the Excel, we are gonna obtain the coefficient of this line, and you see that it has a good consistency because the R2 is 0.99, which is very close to 1, so the coefficient is 0.0062, and then we can calculate k bar, which is the purpose of this experiment.